Let's just be clear about a few little caveats about this. We can always expand the joint probability in this kind of way, in any order we want. We can always use projection, in other words, summing over a particular variable to derive marginal probabilities. In other words, we can eliminate variables that we don't want to get, let's say, if you want, we could squeeze out all the variables between x2 to xn minus 1 and compute from that by summing over all those variables. We could get xn given x1, right? But one very important thing is that basically when you do these kind of projection operations, you should think of it as potentially throwing away information. In other words, we're taking a high-dimensional object, we're squishing it down to a low-dimensional form, and if you want to reconstruct the high-dimensional object again from those lower dimensional forms, you're going to get some kind of, smeared result that doesn't actually exactly match the original high-dimensional object. For example, if we tried to take our marginal probabilities and just multiply them together to try to get that, that's not necessarily valid, right? What it depends upon is how the actual probability distribution, what conditional independence rules it obeys, right? If it doesn't obey any independence whatsoever, there's no conditional independence whatsoever, you're stuck with this form, a high-dimensional form where there's n terms here and no simplifications. The last term is going to have all n variables appearing in that one term, okay? So you're still stuck with an n-dimensional problem in each one of those pieces. Of course, when I told you a moment ago that model building is all about choosing simplifying assumptions, what that means is you're going to propose models whose joint probability actually factors to a simpler form than this. In other words, where, for example, the most complicated term is not going to have all n variables in it. Okay? That's what I mean by a simplified model. A model that reduces the computational complexity of the problem to a manageable size. So the key point that I want to emphasize to you is, of course, we can always take something complicated and squish it down to simpler things. The question of whether the simpler things are actually a complete model that we can just multiply them together and get back the original joint probability distribution, that's a question about the model. If the model structure actually obeys that conditional independence rule, then okay. If it doesn't, then it won't be equal.